Welcome folks. Before us we have a question in chemistry, and as we can see we are dealing with a question that involves more concept. So more concept is a very important topic that you must know, as long as if chemistry is a branch or part of your course, or maybe if you are doing secondary school. So let's look at this question. Calcium nitrate decomposes on heating according to the equation. So calcium nitrate is an ionic compound. Since the nitrate is a polyatomic ion, which is a negative ion, then calcium must form a positive ion. So the products that were produced after this substance was heated were calcium oxide, nitrogen dioxide, and oxygen. So the first question is to copy the equation given and balance it. So the equation is calcium nitrate. Now, to some people, whenever you have a subscript, it may be confusing. But let me see if I can assist one or two on this one. So let's look at how this chemical formula for calcium nitrate came into existence. So remember, calcium is in group 2. So calcium has a valence of 2. Then the nitrate is a radical, it's a polyatomic ion with the charge of -1. So remember, this is +2. Then here we have a -1. Now, whenever we have a compound is neutral. So we need these two charges to balance. So how can we balance the two charges? That's when we now swap the numbers. So the 2 comes here, the 1 will go here, which simply means that we need 2 polyatomic ion of nitrate ions to neutralize the +2 from the calcium ion. So that's what it means by this part here. Now, after this is done, what is our first step when balancing equations? So whenever you're balancing equation, first begin by balancing the metal. So we need to check if the calcium is balanced. So we need to check for subscripts. So here there is a 1. Also here there is a 1. So for calcium, the calcium atoms are balanced on both sides of our equation. Then if you look at the other elements, we need to look at which element are we going to balance here. So we are going to balance nitrogen. Let's not focus on oxygen, since we have oxygen as an element on its own, so it's easy to balance this one. First, let's balance elements that are in compound form. Now let's look at the nitrogen inside. So from the nitrate ion, there is only 1 atom of nitrogen. So we are going to multiply by this subscript, which means that the calcium nitrate as a compound has 2 atoms of nitrogen. So we need to put 2 in front of where we have nitrogen, so that we have 2 atoms of nitrogen on both sides. Now let's check for oxygen. If this 2 is multiplied by 3, we are going to have 6 atoms of oxygen, but on the right side we only have, if you look at 2 times 2 is 4. 4 plus 2, that is 6, plus this one here we have 7. So the equation is not balanced. Now if we are to balance this one, we need half. We need to put 1/2 in front of oxygen. But we don't need this one, we need a whole number. So what happens if you have a case like this one? So if you have a case like this one, I'm going to multiply everything by 2. So that's what I'm going to do. So let me just get rid of this. So we are going to multiply everything by 2. So the first one, I put 2 in front of calcium nitrate, then I also put 2 in front of calcium oxide. So calcium is balanced because 2 times 1 is 2, 2 times 1 is 2. Then if the 2 from the nitrogen dioxide is multiplied by 2, we are going to have 4. So which simply means that there is 4 nitrogen atoms. There is also 2 times 1 is 2 times 2, we still have 4. So nitrogen is still balanced. Then what else? We need to multiply half times 2 is just 2. So if you multiply half times 2, we are going to have 1, which is this one will be left like this. Now let's check if this time is balanced. So 2 times 3 is 6 times the 2 in front, so 12 atoms of oxygen on the left side. Let's check for right side. So we have 2 from calcium oxide. 4 times 2 is 8, plus 2 from here is 10, plus 2 here we have 12. Now our equation is balanced. So if you want more of the balancing of our equations, you can just search. I have a video that is just focusing on balancing of equations. Now after we have our equation balanced, let's move on to question B. Calculate the relative formula mass of calcium nitrate. So relative formula mass is just the mixture for an ionic compound. So for a covalent compound, this one is known as relative molecular mass. So relative molecular mass, let me write it here. Relative molecular mass is for a covalent compound, so that's a difference. Then relative formula mass is for an ionic compound, but the concept is the same. So we say Mr is equal to, so if you look at the periodic table, calcium has the mass number of 40, then the atomic number of 20. Now from calcium nitrate, let's not focus on the balance one, let's just look at the chemical formula for calcium nitrate. So it's like this, right? So from this we can see that there is 1, so we are going to say calcium multiplied by the number of atoms in that compound plus excuse me, we need to now go for nitrogen. So nitrogen has the mass number 14, the atomic number of 7. So there is 1 here, then you multiply by the subscript outside. So this goes by nitrogen times 2 plus oxygen multiplied by 2 times 3, we get a 6. Then after this is done, we just have to replace now each element with its mass number. So calcium is 40 times 1, nitrogen is 14 times 2, oxygen is 16 times 6. So 40 times 1 is 40 plus 14 times 2, we get 28 plus if you look at 16 times 10, we have 60. 60 plus 36, that's 96. So 16 times 60 is 96. You can use a calculator. Calculators are allowed in science. So you just have to find the sum of the 3 numbers. So 96 plus 28 plus 40. So according to my calculations, I'm getting 164 as my relative formula mass. Okay, now we will move on to question C. So under question C, the last one, we are given 16.4 grams of calcium nitrate is decomposed. Calculate the volume of oxygen gas liberated at RTP and pressure. Alright, so the balance equation was like this. So we have calcium. So for you to get the correct answer, make sure that the equation is balanced. So if you just miss by balancing, then you've got everything wrong. So this is our balanced chemical equation. Now our target is we want the volume of oxygen, so the volume of this gas. Now if you look at the formula for volume, is given by this formula. Volume is equal to, number of moles is equal to volume of the gas divided by molar volume. So if we make V the subject of the formula, we have volume, the one that we are solving for, is equal to number of moles multiplied by molar volume. Now we don't have to worry for molar volume, we are given the condition, which is RTP. So our task here is to find the number of moles for calcium nitrate, since the mass is given. So the number of moles given the mass is found by this formula. So number of moles is equal to mass divided by molar mass. Number of moles is equal to, what's our mass? Mass is given 16.4 grams. Now molar mass is the mixture that we calculated. So let's go back. The mixture that we calculated was 164. So we divide by 164 grams per mole. So remember, the units for molar mass are grams per mole. So 16.4, and whenever you're dividing numbers like this, make sure you put the numbers in parentheses so that you get the correct values. So I'm getting 0.1. So 0.1 moles excuse me, for calcium, for 1 calcium nitrate. Now after we are done finding the number of moles of this, how can we use the number of moles for calcium nitrate to find the number of moles for oxygen? So we bring in now mole to mole ratio. So what I'm going to do is I'm going to write calcium nitrate here, then I'm going to put oxygen. Then what am I going to do? So I'm going to get the mole ratio for calcium nitrate. So the number in front is 2. I'm going to put where calcium is. Then the mole ratio for oxygen is 1. So I put 1 here. Then the number of moles that we have for calcium nitrate. So I'm going to put where calcium nitrate is, so 0.1. Then we cross multiply, and so for x. So 2 times x will give us 2x. 0.1 by 1 is 0.1. We divide by 2, we divide by 2. So x is equal to, so I'm getting 0.05. Now these moles are for oxygen. So these are the moles that we are going to replace where N is. So I'm sure you've seen the reason why we went by finding the number of moles for oxygen, because they are needed according to the formula. So number of moles for this one is 0.05 times molar volume. So we are told RTP. So RTP is 24. So if we just multiply 0.05 times 24, then our answer is 1.2. Then the units should always be in decimeter cubed. So that is how we can find this answer. So that's it for this video. Thanks for watching, and if you find this lesson interesting, please subscribe, then hit the notification bell so that you're notified as soon as I post new videos in future. Then comment where necessary. We would also like to hear from your comments. Right, so thanks for watching.